Minasan, konnichiwa, Zamurai Engineer desu. In this video, let us resume our discussion. We are now on 3.4 of our textbook on principles of steel design. So I'm waiting for the confirmation for our sound check. Okay, clear. Thank you, Charlize, for confirming our sound check. So let us therefore proceed. I hope our attendance checker is able to take attendance on each of the live stream. I hope. Okay. Anyway, what I'm going to introduce to you is the effect of staggered holes. Staggered holes. Okay. So, if there are more than one row of bolt holes in a member, so in our given problem, given example, there are holes, but they are in line. They are aligned vertically, aligned horizontally. But there are bolt holes that are not aligned to one another. It is often desirable to stagger them. That is what we call staggered holes. Okay. In order to provide as large a net area as possible at any one section to resist the load. Okay? So, to resist failure of the load. Okay? So, we need staggering the hole for the purpose of getting more area, getting more cross-sectional area with the same number of bolts. Okay? So, for example, in the last figure, we have 8. That's correct. There are 8 bolts. So, having the same number of bolts, we can have a larger net area if we would stagger the holes. Okay? So, having the same number of bolts means having the same effect on joining the members. Okay? We have been joining the members at the same effectiveness because we have same number of bolts. Okay? That's the concept. Okay? So, in the preceding paragraphs, tensile members have been assumed to fail transversely. Why transversely? What do we mean by that? The failure is transverse, like this. Okay? The failure is like this. This is the transverse direction. Transverse. Okay? This is longitudinal direction. Longitudinal direction. This is transverse direction. So the failure is transverse rather than longitudinal. Why? Because why? Because transverse is the shortest path. Okay? Shortest path meaning the weakest line. So which is the shortest path? This one or this one? So this one is the shortest path because there are holes. Okay? Which one is the shortest path? Transverse or diagonal? Diagonal. So transverse is shortest rather than diagonal. Okay? Okay? So, therefore, let's go back. Okay? So that is the they assume failure, transverse. Okay? So, therefore, to determine the critical net area, okay, it might seem logical to compute the area of a section transverse to the member as we already done. It's an example. Okay. However, in this section, we will have another. Okay. So, another presentation of holes, another type of connecting the members, okay, using staggered holes. Okay. So the shortest path, the smallest value of the cross-sectional area that would resist the load, that is what we call critical path, critical value. Okay? Take note, critical value, critical path, that is the shortest line. Okay? That is the smallest value of cross-sectional area that presents resistance to failure. Okay? Okay, so remember those concepts. Okay, now let us show you the figure. Okay, figure. Okay, possible failure section in place. So this is the possible failure, as you can see on the broken lines. This is the possible failure, so as this and so as this. So possible failure. But it is the most possible failure rather than this one, Okay? Why is that? Why it is the middle? Why not the edge? So, it is actually transverse. We are showing you the transverse. It could be this one, could be this one, it could be this one. They are transverse. Now, this one is not transverse because, as you can see, the holes are not aligned vertically and horizontally. Unlike this one, this is aligned horizontally and aligned vertically. This is aligned horizontally, but this is not. Diagonal. Okay? That is what we call staggered holes. Okay? And what is the shortest path? The shortest path is this one, ABE. That is the critical path. That is one path. Okay. We will find out which one is the critical. We will solve for it. We will show the path. The path is AB. The path here is AB. The path here is ABE. Another path, ABCD. Take note. Okay? There are two paths. Now we will compute which one of the two paths which one is the critical path. Which one of the two? Okay? Okay. So we will have a picture of Transworld Dome, St. Louis. Okay. So, let us define some new symbols. Let us define new symbols. Okay. What do we mean by S? Okay. Okay. S and G. Okay. S, okay, is the longitudinal spacing or pitch or spacing. Okay. Spacing meaning pitch. Spacing, we represent it by S. Okay. S. G. What do we mean by G? That is gauge or transverse spacing. Okay. So SG, we need to know what is S and G because we have a formula like this. Okay. Take note of the formula. S squared over 4G. So therefore, we need to know what do we mean by S and G. So again, S is what? Spacing. What kind of spacing? Longitudinal or transverse? This is longitudinal. So S is longitudinal spacing. G is transverse spacing or gauge. Okay? Okay? Remember, we have gauge represented by G, and that is transverse. Okay? So now we already know that we have the formula. Okay? Okay? That is equal to S squared over 4G. Okay? What is the process to calculate? The method is to take the gross width, okay? Gross width of the member, right? What do you mean by gross width? The path, okay? Regardless of the line along which failure might occur, okay? So it is not only transverse, it could be zigzag, just like we shown, okay? It could be zigzag, like this. Like this. This one. A, B, C, D. That is zigzag. This is transverse. A, B, E, transverse. But A, B, C, D, that is zigzag. Okay? That is the path that could fail. Could fail. Okay? So, those gross width, that is the width, meaning the line, if you add the total distance along that line, that is what we mean by gross width. Okay? Okay? Subtract the diameter of the holes along the zigzag section being considered. So we have to subtract. We have to, for example, there are 2 holes, so subtract 2. 2 times the diameter, okay? Diameter of the holes, not the diameter of the bolt, okay? So, okay, subtract and add for each inclined line, okay? For each inclined line, if there are diagonal, what we mean by inclined? Diagonal. For each diagonal line, we have to plus. Take note, we have to subtract and then we have to plus. We have to subtract the number of holes, but we have to add the quantity equal to S squared over 4G. Okay? Do we follow? Do we follow? Okay. Let us find an example. Let us find an example. S squared over 4G. Remember that formula for staggered holes in finding out the path. If we are successful in finding out the critical path, just multiply by thickness. That is the cross-sectional area. Okay, that we are going to use. Okay, so let us compare the critical path, because the critical path multiplied by the thickness, that is the critical cross-section. That is where the failure will actually go along. Okay, so that is the failure path. Okay, 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 let us first take a look at the table. This table is about workable gauges for angles in inches. What do we mean? For example, we have the given angle here. We need to make a hole here at exactly this location, one hole. and then 2 holes on this side. So 1 hole on one side and 2 holes on the other side. What are the required distances? G1 and G2. This is G. So those are the measurement, transverse measurement. That's why it is called G. Okay. For example, leg. Okay. Okay. So if the leg is what? 8 inches. Okay. If the leg is 8 inches, G from this face to the center of the hole, 4.5. Okay? So that is about the center of this flange or this face. Okay? 4.5. G1, G2, 3. Another 3. So 3 and 3, 6. Then therefore this is 2. 3, 3, and 2. Okay? Okay? So from this point to this point is 8. Here, 8. The leg is 8 inches. So 3 inches, 3 inches. So what do you mean by this table? Making a hole is specified, either specified and designed and analyzed. Okay? So it is not arbitrarily guess. We do not arbitrarily guess the location of the hole. Okay? Just what you think is correct, what you feel correct. No, we have the specific location where we have to put a hole and use it for bolt connection. Okay? So if we have what? 2. Okay? For 2 inches. For a 2 inches here, for a 2 inches leg, so 2 inches by 2 inches, so we have 1. 1 and 1/8. 1 and 1/8. So on the other hand, 1 and 1/8. Okay? Meaning, if the size is 2 by 2 inches, okay, we cannot have 2 holes on the other side. 1 hole on one side, 1 hole on the other side. Okay? So, only for 5 inches where we can have 2 holes on the other side. Okay? So, 4 inches and below, meaning from this point to the edge, that is 4. From this point to that edge, that is 4. 4 by 4. For 4 by 4, we have 2.5. 1 hole on one side only. Okay? Very important to take note of that. Now, example number 2. Let us take our example number 2. Okay. Let us determine the critical net area. Take note of the terminology. Net area. Critical net area. So, net area is different from critical net area. Okay? Okay? There is only one critical net area. We can solve many net areas and compare all those net areas. And the shortest path, that is the critical net area. Okay. Determine the critical net area of the 1-inch thick plate shown in the figure. Okay, take note of the thickness, 1 inch. Okay, using the IIEC specification, the holes are punched for 3/4 inch bolts. Okay, so 3/4 inch bolts. Okay, so the thickness is 1.5 inch. So therefore, we have to add. Do we need to add 1/8 or 1/16 here? We need to add. We cannot do it 0 because the thickness is smaller than the bolt diameter, meaning it could easily be punched through. Okay, and easily punching it through would break some of the areas, extended areas. So those extended areas could be represented by either 1 over 8 or 1 over 16. And this author used 1 over 8. Okay, so take note of that. Take note of the dimension. This is 11 inches from this point to this point, 11 inches. And the first hole is 2.5 inches. Then from this point to this point, 3 inches, 2.5 inches, 3 inches, and from the edge to this point, that is 2.5. So 2.5, 2.5, 3. So 5 plus, so 2.5 plus 2.5, 5 plus 3, that is 8. The total is 11. So this is what? From this point to this point, 3 inches. This is 3 inches, the transverse path. But this is an staggered path. This is the diagonal path. This is more than 3 inches. Okay. So this is from this point to this point, 3 inches. So this is what? 45 equilateral triangle, 45 degree equilateral triangle. Okay. So 3, 3, therefore this one is 3 square root of 2. Okay. How much is that? That length is, the length is 3 square root of 2. Okay. So if I may show you the calculator, so let us show you. So that would be 3 square root of 2, that is equal to 4.2. That is 4.24. Okay. So that is 4.24. Okay. And continue, since we already know how to do it, so let us count the number of possibilities. Count the number of possibilities. What are the paths? What are the lines that are possible? Possible A, B, C, D. So transverse line, exactly vertical, transverse path, A, B, C, D. Another possible path, A, B, C, E, and F. Okay? A, B, C, E, F. That is another path. Another possibility, A, B, directly to E, F. A, B, E, F. So how many possibilities? So there are 3 possible paths. Okay? So if there are 3 possible paths, therefore we can compute each of them, and after computing each of them, let us compare which one is the critical net area by multiplying the critical path length by the thickness. Okay? Take note of the thickness. The thickness is given at what? 1/2 inch. Okay, 1/2 inch. So just multiply by that later on. So let us, or if you can immediately multiply by the thickness and compare the area instead of the length. We can do that. Okay. So therefore, let us proceed. Solution. Okay. Solution. So path A, B, C, D. So A, B, C, D. That is very simple path because this is A, B, C, D is actually AD minus 2 holes. Okay, that is AD, and AD is what? 11 times the thickness, which is 1/2. So that is 11 times 1/2, that is the gross area, minus 2 holes. So times 2. What is the hole diameter? The hole diameter. What is the ball diameter? Let us see. What is the ball diameter? Let us see the ball diameter. The ball diameter is 3/4. Right? 3/4. So if we have 3/4 plus 1/8, because this author uses plus 1/8 rather than plus 1/16, take note. So the total is 7/8. So 7/8 is the diameter of the hole. Okay. So therefore, times 2, 7/8 times the thickness. This is the area for the hole. So gross area minus the area for the holes. There are 2 holes, and therefore the answer is 4.63. Take note. That is supposed to be our answer if there is no staggered hole. Okay? There is no staggered hole. That is supposed to be our answer. Now, with the staggered holes, let us go to the next. Okay. Next part is A, B, C, E, F. Okay. So, the same gross area. Okay. The same gross area. But, we have to subtract 3 holes rather than 2. There are 3 holes here. 1, 2, 3. There are 3 holes in the path. Okay? There are 3 holes. So, therefore, 3 times 7/8. 7/8 is the diameter of the hole. As shown here, this is 7/8. Multiply by the thickness. And then, we add what? S squared over 4G. Okay? So, what do we need? S squared. What is S squared? Only for the part that is diagonal. Only here. Because this is the part that is diagonal. What is the S here? The S here is this one, 3. G is the C to this line. This is G. The transverse. Okay? S is longitudinal. Longitudinal is 3. From this point to this point, 3. So 3 squared, okay, divide by 4 times G. 4/3. So therefore, 3 squared divided by 4 times 3. This is the critical path here. This, from this point to this point, that is CE. That is only for CE. We will only compute S squared over 4G on those diagonal lines. Multiply by the what? The thickness. Therefore, if you compute all of this, you will result to 4.56 square inches. Path or cross section ABCD is 4.63. This is 4.56. This is smaller than 4.63. Okay. Next path. ABEF. The next path is ABEF. Take note. I will orally give you the answer for ABEF. ABEF. How many holes? There are 2 holes here. So therefore, it is similar to this one. ABEF is similar to this one. Multiply by the what? By the thickness and minus 2 holes. This is the same. This is the same. But we need to add. What we need to add? This is diagonal from B to E. This is diagonal. What is the value of S? S is 3. What is the value of G? This is 6. So how much? 3 squared divided by 4 divided by 6. Multiply by the thickness, 1/2. So if you compute that, the answer would be 4.81. Again, gross area minus the holes, there are 2 of them, plus S squared over 4G times thickness, the answer is 4.81. You will notice, compare which one is the smallest. The smallest is this one. Therefore, this is the critical path multiplied by the thickness. And therefore, this is the critical net area. This is the net area. Critical net area that we are being asked to solve. Okay? Critical net area. Are we clear? Are we clear? Okay. There is a hint from this. So the answer is 4.56. Right? The reader, you should note that it is a waste of time to check path A, B, E, F for this plane. So you need only to check this one and this one. This one and this one. Okay? Okay? 2 holes need to be subtracted for rows A, B, C, D and A, B, A, F. So there are 2 holes here. There are 2 holes here. No need for this one. So no need for these 2 because this would give you bigger. Why you have to compute this? This one is equal to this one. This one is equal to this one. This one is equal to this one. And this one is plus this value. Therefore, it is bigger because there is another addition. You have to add another. Therefore, this is bigger. That's why it is only a waste of time if you have to compute this. Okay? So, you just need to compute this one and compare. Therefore, you can find out. Okay? That is our answer. Any question? Any questions so far? Okay, last example. Let's do this example number 3 faster, okay? Because we already know how to do it. So example number 3. For the 2 lines of bolt holes shown in figure below, so this is the figure, determine the pitch that will give a net area DEFG equal to the one along ABC. So DEFG is equal to ABC. Okay? Okay? Determine the pitch. What do you mean by pitch? This is the pitch. Pitch is S or the longitudinal path. Okay? The longitudinal. So this is S, longitudinal. That is we mean pitch. This is gauge. So pitch and gauge. Okay? So recall the name pitch and gauge. Pitch is longitudinal, gauge is transverse. Okay? So how much pitch must be designed so that ABC is equal to DEFG. That is a very good. This is a very good problem solving. Okay? So therefore, we know that there are 2 inch, 2 inch, 2 inch dimension. What is the thickness? The thickness is not given, but we will only compare the length. We will compare the length because anyway, both the thickness for either of the path, they are equal in thickness. So we will just compare the path, the length of path. Okay? So whichever is the shortest path, that is the one critical. But here, we will make this both path critical by making them equal to each other. So let us make them equal to each other so that they are both critical path. Okay? What is the size of the bolt? 3/4. So 3/4 plus 1/8, that is 7/8 inch. Okay? 7/8 inch diameter holes. Okay. So therefore, let us compute for ABC. ABC minus 1 hole. Therefore, 1 times 7/8, that is the diameter. So the path is 5.13 inches. Okay? So the distance from A to C is 5.13 inches because we subtracted the hole diameter. Okay? What about this path? There are 2 holes now. So therefore, DEFG also 6 inches because 2 plus 2 plus 2, 6 inches. That is the what? That is the cross. Okay? Minus 2, there are 2 holes. Okay? Minus 2 times the diameter of 1 hole. So 2 times that. But we need to plus S squared over 4G. We don't know S. Therefore, we know 4G. G is what? From this point to this point. That is equal to 2. So 4G. Okay? And therefore, this expression must be equal to 5.13. That must be equal to 5.13. Okay? Okay? Because they must be equal. Okay? 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 4.25. Okay? This part is 4.25 plus S squared over 8. This is 4 times 2, 8. So, equate 5.13 is equal to 4.25 plus S squared over 8 and solve for S. Okay? So, let us do that. So, let us do that. So, we have our calculator here. So, we have what? 5.13. So, we have 5.13 inches must be equal to 4.25 plus S squared over 8. So, we must subtract this with 4. Okay, that is not correct. Minus 4.25. Okay, and then equal sign. This must be equal to S squared over 8. So that must be multiplied by 8. Okay, and this value is equal to S squared, and therefore we need this to be square rooted. So let us take the square root of this. Therefore, the answer must be 2.7, okay, or 2.65 for 3 significant figures. So the answer should be 2.65. Okay, let us look at the answer. So the answer have to be 2.65. Okay. So 2.65. What is the answer from the book? So the answer from the book is 2.65. Okay. Again, that is the end of our discussion right now, all about staggered holes. Okay. Again, I would wait for 15 to 30 seconds and give you opportunity to ask question. Any question? So according to Daniela's 2.65, Joshua 2.65 inches. So those are the correct answer. Okay. So there, the answer is 2.65 inches. So I think there are no questions. Looking at the comment box below. Therefore, I would advise you to rewatch, review, and do the examples, do the problem solving in the book, and any other book, do the problem solving in any other. Not only in our book, not only in our textbook. The more textbook you use, the better you will become. But do not focus on simultaneously. Just only focus on one book. Okay? I recommend this McCormack and the author McCormack, no? And Chernak. McCormack, Chernak is the author of this book. I recommend them, but you can use any book you like. Okay? That is my recommendation. Okay? And I will use that book. But you can use any book you like. However, focus yourself in one book. If you decide to use your own favorite book, favorite author, you may do so. Okay? But focus on that explanation. And use their example, use their problem solving to practice. Okay? What do you mean by that? You don't need to read those explanations, those paragraphs anymore. You just need to read those paragraphs, those explanation, those discussion from one author, from one book author. Okay? Do not do all of the explanation from all of the authors. To avoid confusion. You will get confused. You will read all the explanation. Just read one author explanation. Then, use their problem solving, use their example in order to practice. Okay? Okay? Now, if there are times that you are given terminologies, that you are given unknown words or known specification, okay, that is the only time, or unknown line of solution. So there are solutions. So what we mean by line of solution is the process, this line by line by line by line and so on up to the result. That is line of solution. So if you have question on the lines of solution of other authors, other from the book you chose to focus on, okay, then that is the only time that you have to read their own explanation. Okay? That is the only time you have to read their own explanation. Why they have a different line of thoughts in their problem solving. Okay, so that's all for the day. As I've seen and given you the opportunity to ask questions, I am assuming that everybody listened and understood today's lecture. Thank you. Again, this is Dr. AP, preaching engineering for nation building. See you next week.